8-4, direct joint and inverse variation. We're going to look at 3 different types of problems, basically describing how x and y vary from each other. So direct variation is simply just y equals some number times x. When you graph a direct variation, it just simply graphs a straight line. Like here's an example. If I say y equals 3 times x, it goes through 0, 0, and my slope is 3 over 1. So this is an example of a direct variation, where the x value is just multiplied by 3, and you get the y value. Okay, so when you're solving a direct variation problem, we can typically use proportions. Here's how the proportions are set up. Set up the first y value over the first x value, and set it equal to the second y value over the second x value. Here's an example. So if y varies directly as x, they're always going to tell you what kind of variation you have. It varies directly. Y equals 12 when x equals negative 3. Find the y value when x equals 16. There's your proportion. Y equals 12 when x equals negative 3. So find y when x equals 16. I've set it up with the 2 y values on the top and the 2 x values on the bottom. Now we just cross multiply 12 times 16 and divide our answer by 3. So 12 times 16 equals 192, and then we're going to divide 192 by negative 3. And our answer is negative 64. Here's another one, but we're using r and s instead of x and y. And I actually have a typo up here. If r varies directly as s, I should say, and r equals negative 20 when s equals 4, find r when s equals negative 6. So here's your r1 and your s1. I'm going to put up the fraction as r over s, so negative 20 over 4. Find another r value when a different s value equals negative 6. So we're looking for r when s equals negative 6. So I'm going to cross multiply negative 20 times negative 6. That's 120. Then I'm going to divide by 4. So r equals 30. Now if you take a look at the 2 fractions, you know our constant of variation here. Negative 20 over 4 is 5. 30 over negative 6 is also 5. So if you wanted to write the equation, you could say that r equals 5 times s. Okay, moving on. Another type of variation is a joint variation, and this is where y will vary with 2 different, numbers times x. So it looks like y equals k times z times x. It's also going to graph a straight line. Just going to draw it in, and it should go through 0, 0. Here's your proportion. y1 over x times z equals y2 over x2 times z2. Here's an example. So this time the sentence starts very similarly, but it says jointly in here. Y varies jointly as x and z. Find y when x equals 8 and z equals 3. So here's your first fraction. We don't know what y is, but we know that x is 8 and z is 3. And on the other side, if y is 16 when z is 2 and x is 5. So we put the y values on top and we're multiplying x times z in the denominator. So what you need to do is multiply these numbers first before you cross multiply. So I'm going to say y over 8 times 3 is 24 equals 16 over 10. Now let's cross multiply 24 times 16 and then divide that answer by 10. And we get 384 divided by 10. So y equals 38.4. Let me show you one more of these. This time r varies jointly as s and t, so when it says the word jointly, you know which proportion to use. Find r when s equals 2 and t equals 8. If r equals 70 when s equals 10 and t equals 4. Now, how did I know that r should be the y value, the one in the numerator? It kind of starts up here. Suppose that r is the one that varies jointly as s and t. So that means r represents that y value, and s and t represent your x and z. So the proportion we have here is r over 16 equals 70 over 40. Now we're going to cross multiply and divide. So 16 times 70 should equal 40 times r. So we're going to multiply the numbers, divide by 40, and that'll leave us with r. Sorry about that pause, and we're left with r equals 28. Okay, there's one more type of variation, and this is called the inverse variation. So instead of a k times x or k times your x value, we're dividing k over the x value. So it's actually a rational function, and rational equation, I should say, and the x value here, remember, cannot equal 0. So when you graph it, you end up with a vertical asymptote at 0, and you end up with two pieces to your graph. I'm not drawing this very accurately, but that's what the graph looks like when you have an inverse variation. Take a look at how we set it up. We're putting the x values in the numerator now. We're also kind of crisscrossing x1 and y1 and x2 and y2. So you're going to take the first x value over the second y value and set it equal to the second x value over the first y value. Because it's an inverse variation, this is how we want to set it up. So here's our example. R varies inversely as t. R equals 18 when t equals -3. Find r when t equals -11. Okay, so what we really have here, think of r as your y value, t as your x value. We have r1, t1. We need to find r2, and we know t2 is -11. Okay, so here's how I would set it up. T1 is -3 over R2 is what we're missing. On the other side, we've got -11 over, which is our second T value, over the first R value, 18. So I put the T's on the top and the R's on the bottom. I've also swapped them. -3 and 18 are across from each other. And then the second part of the sentence, after the comma, we're looking for R when we know that T equals -11. So let's cross multiply. -3 times 18 gives us -54. We're going to divide that by -11. Oops. And we get 4 10/11 as a mixed number. Okay. I'll show you one more of the inverse variation. Notice it says x varies inversely as y. So x1 equals 24, y1 equals 4. Find x2 when y2 equals 12. Okay, so we want to set it up like this. 24 over 12, the first x value over the second y value, equals the second x value over the first y value. Now let's cross multiply and then divide by 12. 24 times 4, and then divide that answer by 12. So we get 96 divided by 12, and that gives us 8. Okay, and that's it for this lesson.